HBAT illustration of meditation. It's meditation and meditation effects on the factor analysis. We'll talk. The HBAT model shows in the figure 4 hypothesize several meditating effects. The relationship of both exogenous construct, environment, perceptions, we call it EP, and attitude towards co-workers, AC, with staying intention, SI, are hypothesized to be fully meditated by two endogenous constructs: job satisfactions, JS, and organizational commitments, OC. The model hypothesized that the effect of EP and AC can be fully explained through the test to meditating construct. We examine model fit as an explanation of the overall set of relationship and confirmed the model, but we can also explicitly test for meditations as described above. Let us examine the possibility that the relationship between EP and SI is meditated by the two constructs of JS and OC. To do so, we will follow the two-step process just described. Number 1, the step 1, we call it established significant relationship between the constructs. In this situation, we can refer to the correlation between the construct in the confirmatory factor analysis model. From that analysis, not performed in detail here, we can first see the EP was significantly related SI 0.56, ensuring that the direct unmeditated relationship was significant. We also find that EP was significantly related to both JS 0.24 and OC 0.50, establishing a relationship with both potential meditators. Finally, SI was significantly related to both JS 0.23 and OC 0.55, thus supporting relationship between the meditators and the outcome variable. Here we talk about the step 2. Estimate the meditated models and assess level of meditation. In this analysis, we will first use the original employees related model, which is described in the figure 4, which did not estimate the direct effect from EP to SI. To assessing, adding the direct effect would substantially change the model fit. We can estimate a revised HBAT model denoted path in figure 4, which adds the direct path between EP and SI. This is a figure 4 adding the direct effect for testing the meditations in the HBAT employees retention method. Visually represent the parameter estimate to initials, respecified direct effect, added models, statistically significant at 0.05 level. The revised model with the direct relationship had the significant decrease in the chi-square, a substantive improvement in the model fit, and the significant path at essential model for the EP. SI relationship already seen in table 4, the results suggest that there is no complete meditations. In the revised model, the past estimation between the EP and the both meditator JS and OC are still significant. These are the effect which is described in the table, and it's a table 4 testing for the meditation and the company employees retention models, model element, but employees retention model and revised model. These are the model fits and standard parameter estimation. EP and SI not estimated, statistically significant at 0.5 level. The magnitude of any individual meditating effects can be calculated using the prawns to calculating indirect effects. If this is done, you will find the most of meditating effects come from the EPOC-SI meditating relationship. Given this post-hoc theoretical analysis, HBAT needs to cross-validate this result with new data before the considering it reliable. However, managerial implication for each of the supported hypotheses can be developed based on overall results. Let's talk about the moderations, which I had already discussed about that mediation and moderation. These are the effect researcher usually use while doing their factor analysis, and we can use this in ANOVA, MANOVA as well as. A moderating effect occur when the third variable of C construct change the relationship between the two related variables. Construct, for example, we do say that the relationship is moderating by the gender if we found that the relationship between the two variables differed significantly between male and female. Suppose the relationship between the two variables may be negative for male and positive for the female, or significant in one group and not the other. In this type of situation, we would need to know whether the respondent were male or female before could accurately estimate and interpret the relationship. We have discussed moderators in the other multivariate technique. In multiple regression, for example, there were interactions term where the regression coefficient changed based on the value of second variable. In ANOVA, MANOVA, interactions effects were used to assess where the differences between the group were constant across the values of another variable. In both of these examples, the interactions effect are the fact moderators. It is important to note that moderating variable must be chosen with the strong theoretically support. The assumptions can ability by the moderator is one that cannot be tested directly and become potentially confound. The moderators become correlated with either of the variables in the relationship. Therefore, analysis is of moderators is easiest when the moderators has no significant linear relationship with either the factor construct. The lack of relationship between the moderator and the other construct help distinguish moderating from mediators. Remember that mediator must be related to both construct in the relationship being mediated. As multicollinearity increase between the mediators and the other construct, the causal interface is called into questions, making a valid interpretation of increasingly difficult. Let's talk about the non-metric moderators. A moderator's variable can be matrix or non-matrix. Non-matrix calculate categorical variables often are hypothesized to be moderators. These moderators typically are classified gender, age, or other characteristic differing situations, or where the country of the original become a moderating variable. Similarity, dividing respondent into the current customers versus known customers would be using the customer status as the moderator variable. As noted earlier, theory is important in evaluating a moderator because a researcher should find some reason to expect that the moderator changes a relationship. Researchers have any number of ways for dividing the sample into groups, but the section of a moderator should not be based on the whether it demonstrating significant moderating effect, but rather on its theoretical foundation. When the moderator variable is selected, group of the respondents can be defined and multi-group analysis applied. The procedure is similar to that described earlier in the discussion of the invariance testing, which the primarily differences being that in moderations the focus is typically on structural model estimate rather than on the measurement model. Let's talk about the metric moderators. A moderators can also be a continuous matrix variable and evaluated using the structure equation model. If the continuous variable can be categorized in a way that makes sense, that is based on the theory or logic, then groups can be created and the same procedure used for non-metric moderators can be applied. For instance, if the continuous variable shows by bimodality, that is the frequency distribution shows two peak rather than one, the logical group could be created around each mod. As an example, just the factor could be the measure metrically, but if there is a highly satisfied group versus a moderated satisfied group, then the two groups defined by their feeling about satisfaction would be used as a rating variable. Cluster analysis also might be useful to from groups. However, if the moderators variable display a clear model distribution on peak, the grouping is not justified. It is possible that some faction, that is one third of the observation around the median value, could be deleted and remaining observation which are likely non-biomodal used to create groups. An obvious drawback to this approach is the increased cost, time and effect associated with the need to gather a sample. The advantages is the multiple groups analysis can be used, providing an intuitive ways of testing or demonstrating moderation. Researcher also can model a metric moderators by creating terms and when using the regression approaches. Using regression terminology, in deep independent variable can be multiplied by the moderator to create an interaction term. However, taking this approach with multiple construct is completed by the numerous factors. This topic is beyond the scope. On this text, a brief introduction is provided on the website. This is the website where you can visit and see the brief introduction if you want to know about that. But we encourage all but the advantages user to apply the non-metric multiple groups approaches unless it could not be justified. Let's talk about the using multi-group structure equation modeling to test moderation. Multi-group structure equation modeling is used to test moderating effects. When the moderating variable, either non-metric or metric moderators, has been transformed into a non-metric variables. See in previous descriptions, moderation typically involves the testing of the structural model estimations. Thus, the process become an extension of the multi-group analysis for testing measurement invariance. As an initial step, sum from the metric invariance must be established before examining any differences in structural model estimate. With measurement invariance established, the structural model estimate in the assess for the moderation by the comparison of group model. Much like invariance testing, the first group model is estimated with the calculating separately for the group. This is identical to the TF totally free model described earlier. Then the second group model is estimated where the past estimate of interest is constrained to be equal between the groups. Comparison of the differences between the models with a chi-square differences test indicate if the model fit decrease significantly, that is the increase in the chi-square, when the estimation we constrained to be equal. A statistically significant differences between the model indicate that the path estimation were different. That is, model fit was significantly better than separate path estimate were made, and the moderators and the moderations does exist. If the model not significantly different, then there is no support for moderation because the path estimation were not different from the groups. When the testing for the moderations, the researcher is looking for the significantly differences in the two models to support the hypothesis of the differences in the path estimate. The researcher should also examine the path estimates in the questions to assess if the differences in both group models are theoretically consistent. Let's talk about the HBAT illustration of the moderation. HBAT management team suspected that men and women may not exhibit the same relationship in the role of the variable attitude towards the co-worker may play the creating job satisfaction. Theory would suggest that there could be the gender differences in the relationship whereby the effect could be greater among women relative to men. This is a table 6 testing the gender and the moderator H. BAT employs retentions models, and here is a model characteristics unconstrained group model. This is a constrained group model and model differences. When the employees retention model found a non-significant relationship between the AC-GS quotients across the perhaps the common path estimation from the combination both group was not reflecting the actual differences between the groups. As a result, the Bhatt research team decided to conduct the multi-group analysis using the genders classification variable. Multi-group confirmatory factor analysis established metric invariance as described earlier in this chapter. This was sufficient to now test for the moderating in the relationship between the construct, specifically the AC to JS relationships. Following the same step used to specify the two group confirmatory factor analysis model testing for the differences based on the gender, a two group structural model was set up. The TF structural model estimates an identical structural model in both groups simultaneously. The model fits statistically and the path estimation for the AC-GS relationship are shown in the table 6. Then a second group model is estimated, the only differences being that A to JS path estimated are constrained to the equal in both groups. The fit result and the path estimator are shown in the table 6. These are the explanation about the moderator effect and illustration of the company. Let's talk about the longitudinal data. Structure equation modeling is increasingly applied to the longitudinal data. Given the added insight from the tracking the changes in construct and relationship over the time, the increasing use of the longitudinal data may be beneficial in many fields because many different type of the longitudinal study design lead to many different structure equation modeling applications. This section provides only a brief introduction to some of the key differences in dealing with the longitudinal data. The interested readers is referred to other sources for more detail in discussing on the review. Here we talk about the mediation and moderation. Mediation involves the comparison of the direct effect between the two constructs while also including an indirect effect through a third construct. Full mediation is found when the direct effect becomes non-significant in the presence of the indirect effect, whereas partial mediations occur when the direct effect is reduced but still significant. Although indirect effects that are small, less than 0.83, are generally not of interest because they are likely trivial relative to the direct effects, the combined total of all indirect effects may be substantial. Moderation by the classification variable can be tested with multi-group. In structure equation modeling, a multi-group structure equation modeling first allow all hypothesized parameters to be estimated freely. Then a second model is estimated in which a relationship that are through the moderated are constrained to be equal in a groups. If the second model fit as well as the first, moderation is not supported. If it is a significant worse, then moderator is evident. The multi-group model is convenient for the testing moderation. If a continuous moderating variable can be collapsed into the groups ways that make sense, that group can be created and procedure described previously can be used test for the moderation. Cluster analysis may be used to identify groups for multi-group comparison. Unidimensional data should not be split into the groups based on the sample mediation split when using the continuous variable moderator form as a construct interactions. The direct relationship between the predictor construct and the outcome construct and between the mediator moderator construct and the outcome construct should be estimated only the relationship between the construct in interactions and the outcome is significant. Large sample size are needed to accommodate the continuous invariable interaction. Let's talk about the additional covariance sources timing. One of the key issue in modeling the longitudinal data with the structure equation modeling involve added resources of covariance associated with the taking measurement on the same unit over the time. For instance, consider a model hypothesizing that reliability to cause math ability the theoretical relations may be in the fact that need to be able to read the adequately study mathematically. Suppose that longitudinal data available that the math and reading ability the each treated at the latent construct measured by the multiple indicator. Math ability is any given time could be more modulated as a function of reading ability in the time. Reading ability in the previous time period and the math ability in the previous time period. A significant reading ability in time period. Math ability in the time period t is equal to relationship would help provide the evidence of the causality in that it would be consistent with the causal timed sequence and establish covariance. It is easy to see how the model could be extended to more time periods. One key issue is the whether is it is the reasonable to expect that the matching indicators measures in the differences time periods are unrelated. In other words, if the reading speed is an indicator of the reading ability construct in each time period, should the correlation between the reading speed indicator test the time and the reading speed indicators test in the time to be models? Generally speaking, the answer is yes. Let's talk about the using error covariance to represent the add covariance, including of a measurement error, covariance term, or an adding the construct that is seen as another cause of the matching indicators will represent added covariance. Figure 5 shows in a part diagram illustrating the cause of the error covariance parameter to capture the additional sources of the commonality. Each part that must be estimated is indicated with an arrow. Noted that the two-headed curve arrows are now shown from the each measurement variable error term between the matching test. In other words, the first reading test is the same applied in the both time periods t and t minus 1. So a student score on each should be correlated. The same can be said for each of the four separate math tests. In this way, an attempt can be made to control for the additional sources the covariance that emerge from the use of the longitudinal data. The attempts at control quickly become complicated as the number of construct and the variable increase, and across the differences type of the illustrations involve the longitudinal data, but the model enable a closer examination of the transfer effects can help to establish the time sequence conditions for causality. A final causation is that the increased number of the parameters estimated may at times lead to problems with statistically identification. Another way in which longitudinal analyses are conducted with the structure equation model is to track changes is correlations over the different time period. Assume that data from the structure equation model has been collected for. This is the label score at time. The reading test is T at T1 to test 3 to test 4, and here is a math test. This is the reading the correlation between y, y2, y3, and the intercorrelation math, mediation and moderator, structure equation modeling, longitudinal data of the diagonal covariance terms of model correlation, matching the measurement across the differences period. Three differences time periods. A multi-group analysis can be conducted over the three group time periods to track the potential changes in construct means correlation. A relationship the process follows as a sequence much like to be multi-group process. For moderating described earlier, for instance, a model setting a particular relationship to be equal across all three times periods can be tested against a model allowing the relationship to be estimated in the different time periods. Then the first for the two models can be compared to see whether the relationship is stable over the time. This is the partial least squares. Partial least square PLS has become increasingly popular as an alternative to structure equation modeling. Like SREL, AMOS, or similar programs, originally developed to econometrics. In first gain, a wide separate application in semometric research and has more recently been adopted in a research in business education and a social science. Although there are some differences, terminology in a PLS and structure equation modeler program, the basic specification of the structural model can be similar. Although the structural model might look identical, there are substantive differences in terms of almost every aspect of the developing, estimating, and interpreting a proposed model. Both PLS and the structure equation modeling have advantages and disadvantages, which we will discuss. As you will see, there is no clear cut winner in terms of estimating model with the latent construct. It beyond the scope of this text to provide an executive comparison between the method. What will provide is some representative and the most suitable application and caveat found in each approach. Characteristic of the PLS. Here we talk about the characteristics. Let's begin with the brief description of the PLS, focusing on some of its distinguishing characteristics. First, PLS specify relationship in terms of measurement and structural model, which are termed outer and inner models respectively. It can be delay type of the data from the non-metric to metric with very minimal assumptions about the characteristics of the data. PLS handle both reflective and the formative construct, and all the recursive model are identified even with a single item construct. It differs and implied in the name in that PLS is estimated with the regression based on method rather than MLE, and PLS focus on explanation of variance. Prediction of the construct rather than covariance explanations of the relationship between the items, and significant testing of the parameter estimate is not possible without using bootstrapping methods. PLS is now available in graphically interface programs as well as in module in major software packages, SAS, SPSS, and even structure equation modeling program as such as LISREL. For example, are variations of PLS available in within the SAS statistical software is easy to use. All the research need to specify is the intended outcome variable, the set of measurement variable that may predict it, and the number of factors that exist within the set of items. The researcher does not specify a factor patterns in the type of application. The core of the differences between the PLS and structure equation modeling programs, it is a fundamental objectives. PLS statistically produce parameter estimated that maximize explain the variance, much as was the case with the OS multiple regression. The focus is much more on predictions. Structure equation modeling, however, tries to produce and observe covariance among the measurement, which make is more oriented towards how well a given theory as represented by the structure equation model explain these observation. Those the structure equation modeling is more concerned with explanation and it is more appropriate tools for the theory testing. PLS does not provide a test of theoretical fit. The distribution is hard to conceptualized. We will therefore review some specified advantages and disadvantages of PLS and offer some suggestion on its use. Advantages and disadvantages of PLS. PLS has several advantages and disadvantages related to the structure equation modeling. The advantages lies mainly in its robustness, meaning that it will provide solutions even when problems exist. Then, may prevent a solution in structure equation modeling. First, poor management. Measurement is one of the major obstacles to getting a structure equation modeling solution. For instance, when a researcher is attempting to test a structure model with a single item measurement of a mix of the several single or the two item measurement, PLS may be options because the identification problem that may occur with the structure equation modeling, as we have noted, all the recursive model are identified do not exhibit statistically identification problem in PLS even with single item measurement. Those while validating one and two item measurement is to context of the measurement theory has little meaning with the structure equation modeling. PLS is uninhabited by the such concerns. PLS also handle both formative and reflective construct. Many researchers have utilized PLS for just this reason. Given the perceived difficulties in formative models specification in structure equation modeling, PLS also can be useful way of quickly exploring a large number of variables to identify a set of the variables principles components that can predict some outcomes variable. PLS does not face the issues of model complexity and the structure equation modeling does and is therefore able to handle the large number of measured variable and construct easily. Finally, PLS is insensitive to sample size, considers it estimation approach handle both very small and very large sample with the more is those the structure equation modeling. PLS in particularly useful in generating estimations even the very small sample 30 observation or less where the structure equation modeling program are just not applicable. But with these advantages come some disadvantages. The primary disadvantage of PLS it is the focus on prediction rather than the explanation. As noted earlier, this is the difficulty concept and under the standard, but it is reflected in the fact that the PLS will obtain solutions when the structure equation modeling will fail. Some individual might value a technicals that always give result, but the important considerations where is that we must understand what the result mean and how they are to interpreted. We will use a simple example to highlight these differences. Provide a comparison of LISRELs and PLS in an example with the four measurement variable and two construct. As the demonstrated vastly differences solution are obtained using LISELS, it's a software, versus PLS methods. The LISREL solution produce a path estimated between the construct 0.83, which is the higher than any of observation correlation, whereas the PLS path estimated of 0.22 is much closer to the observed correlation. Moreover, the factor loading are much higher in a PLS model, but not of the loading in the LISREL's model meet the acceptable level, those the construct availability is the questionable. A course can made that the PLS model is useful when the measurement is poor, but we must make the statistical consideration the purpose of the PLS, which is predictions. To understand the differences with with the LISREL and the emphasizes emphasizes on explanation. Look at the measurement model result, the LISREL result. This is the correlation matrix x1 x2 y1 y2 x1 x2 y1 y2. Here is the partial least square result, and this is the LISREL result. Comparison of the LISREL and the PLS estimations indicate that the both construct do not meet the criteria for convergent validity discussed earlier. All of the LISREL loading are below acceptable level. If we calculated reliability and AVE values, they would be allow acceptable standards as well. So is this just a failure of LISREL in comparison to PLS? The answer comes from an examination of measurement model. From a measurement theory perspective, we would conclude that the two constructs are unacceptable and latent construct and would not proceed. Looking into inner item correlation, we seen that they are 0.087 and 0.272, neither of which meet the suggested level. This would lead us to conclude that the indicator do not support construct validity of the latent construct, and thus the model should not be estimated. The failure is not in that technique, but the fact that the specified construct do not meet the requirement of the latent construct are required by the structure equation modeling approach. It is assumed that the construct exhibit adequate reliability and the validity. This is an example of just such a situation where a poor management model impact on the structural relationship. But consider the following questions, because PLS provide the loading estimation that are in the acceptable range. Aren't the latent construct valid? The differences arise from the factor that our loading of the measurement variable for the exogenous construct in a PLS are based on their predictions of the endogenous measurement variable, not their shared variance among the measurement variable on the same construct. Those the loading in the PLS solution are in a way of their contribution to the path estimations. This may seem similar to structure equation model, but is it quite different that the loading now dependent on which exogenous construct they are related to? As such, they are more susceptible to variations when moved from one model to another. If the other construct model change, this is the construct of the structure equation modeling approaches in which the emphasis is one construct validity respective of the other construct in the model. PLS provide no omnibus test of the measurement model as it is case with confirmatory factor analysis. Let's talk about the choosing the PLS and versus structure equation modeling. Conceptually and practically, PLS is sing, similar to multiple regression analysis to examine possible relationship with the less emphasis on the measurement model as a separate and a distinct submodel. PLS certainly can address a wider range of the problem given its ability to work efficiently with a much wider range of sample size and model complexity, and it is less strict assumptions about the underlying the data. Moreover, the lack of emphasis on the measurement properties of the construct make it more amenable to the use of the construct with fewer items, for example one or two, than are required for structure equation modeling. Those in certain cases, particularly when measured, are the problematic, and the emphasis is more an explanation than the confirmatory. PLS may be an attractive alternative to structure equation modeling. Yet, although the PLS can be applied to a wider range of situations, the researcher must always be aware of the differences in interpretation of the result, particularly as they related to the measurement properties of the construct. It is appropriate to return to the PLS when the measurement theory fails to withstand the security of the confirmatory factor analysis and subsequent test of convergent validity. PLS still provide the estimates of the relationship between the model construct, but it is incumbent on the researcher is these situations to the quality result based on the adequately of the measurement. As the concern for the good measurement equally increase and the multi items measurement become available to latent construct, PLS is not reconnected and alternative to structure equation modeling. Similarity, PLS can procedure result even with a very small sample, even less than the number of the variable. These may useful to exploratory purpose, but in generalizability of this result is limited by the small sample to no matter what statistical approaches is used. The calculation of the another do not recommended one technique over the another in all situations, but we do strongly suggest that the researcher understand the differences for the which each approaches was developed and used them accordingly. Thankfully, it has been our experience that model with good measurement properties seems to react very comparable result. Moreover, issues use such as the appropriate use and interpretation of formative versus reflective measurement are still found with each approaches. It is those instances in which the measurement properties are in doubt that the result may diverge, and those require the respondent judgment by the researcher on which approach is most appropriate. Let's talk about the rule 5, longitudinal data and the PLS. Longitudinal data is one situation in which correlated items just justify to accommodate covariance of the same indicator across the time period. PLS is an alternative approach to structure equation modeling and is well suited for the sample size either much smaller or the larger than the generally accommodated by the structure equation modeling approaches. Situations where emphasizes more on predictions versus explanation, the measurement model properties do not permit the use of the structure equation modeling. PLS can be provide result with a sample too small and use of other approaches at the needed in the generalizing result to the small sample no matter the technique. This is all about the PLS and the softwares about the factor analysis, and next video I will talk about the summary